All right, so we're going to do a little bit of practice time before we have your work time. You should have a worksheet. I'd like you to follow along. We're going to graph these translated exponential and logarithmic functions. We're going to start with the same way we always do. We're going to ignore the translations. All right? So what do we got here? Well, we got A equals 3 and B equals 2. And a typical normal XY chart, using our common points, -1, 0, and 1, for the x now because it's exponential. The starting value on the x when x is 0, the starting value is 3. To get bigger, when x gets bigger, to get bigger on the y, you'll double it, multiply by 2. 6 times 2 is 3. To go backwards, you'll divide. 3 divided by 2 is 1.5. Now let's go back, look at our shifts. You can see that the y's, we're going to add 5 to all the y's. So add 5, we got 6.5. Add 5 to that y, we got 8. Add 5 to that y, we got 11. And if we plot, or before we plot, make sure, look what we got for the x's. It's x minus 4. It's opposite when it's, excuse me, opposite when it's inside the function. So we're going to, instead of subtracting 4, we're going to add 4 to all of these. So that becomes 3, 4, and 5. So the points we want to graph are 3, 6.5, 4, 8, and 5, 11. We'll go ahead, we'll plot those. 3 and 6.5 right here. 4 and 8 right there. And 5, 11 is just above the graph. Remember, we have an asymptote. Normally goes through right here. We got to translate the asymptote too. We're going to move that 4 right and 5 up. Moving it left and right really doesn't change it, so we just need to worry about going 5 up. So there's our new location of our asymptote. The equation is y equals 5. Same as what we're adding on there. And then when we plot our points, we can connect. And there's our exponential graph. Right? Our next one. Identify our A and our B. Our A is 3. Our B, in this case, is e to the point 2, which is approximately e to the point 2. It's approximately 1.22. All right, we'll make our XY table. I'm leaving some space because I know I'm going to add something to the x's. So that's why you see a big gap there. My y's, we're going to start at 0 of 3. And to go bigger, we're going to multiply by e to the point 2. So 3 times e to the point 2 is approximately 3.66. And to go backwards, we'll divide. 3 divided by e to the point 2. We got 2.46. Now as we look at our shifts, the only shift is right there, outside of the exponent, so we're going to take all of the y values and subtract 4. 2.46 minus 4 is -1.54. 3 minus 4 is negative 1. And 3.66 minus 4 is 0.34, negative 0.34. All right, take our asymptote. Should be normally right there. Remember, we have a shift on. Shift it down. Take our asymptote and shift it down. Right there, and plot our points. Okay? There's nothing here, so we can use those. Negative 1, negative 1.54, approximately there. 0, negative 1. And 1, negative 0.3, right about there. And we got a nice smooth curve, and we go up. Moving on, we have a log. Well, it's the same thing. We need identifier A and B. A is 2 here, B is 4. So as we make our chart, remember it's a log, so we're going to do it backwards. Instead of putting a negative 1, 0, and 1 in the x's, we're going to put them in the y's. Okay, our starting point is 2. To get bigger, we're going to multiply by 4. And to get smaller, we're going to divide by 4. And now we need to see what are our shifts. There's nothing inside, so there's no left or right shift. The x's can stay the same. But outside, we got plus 3. So we'll add 3 to all the y's. And we'll plot points. Remembering our asymptote is right here, and since there's no left or right shift, we do not need to move our asymptote. So as we plot our points, our first point is 1/2, 2, which is right about here. Our next point is 2, 3, it's right about there, and our last point is 8, 4. It's right about there, and we got ourselves a smooth curve through there, a logarithmic curve. Okay, our last graph, then we're going to go back through and talk domain and range for each of those. Same thing, make your XY table, identify A and B. Okay, A is 1 because there's nothing divided by the x. B is 3. So our y's would be negative 1, 0, and 1. We're starting at 1. As we get bigger, we multiply by 3. As we get smaller, we divide by 3. Our y values, we're going to add 3 to all of them. So our y values become 2, 3, and 4. Our x values, we're inside. It says minus 4, so we do opposite since it's inside, and add 4. And we'll plot this. Remember, we have an asymptote that hangs out here. We need to do the shifts with that. We need to shift left and right and up and down. Up and down is not going to change anything because it's a straight line up and down, so we just need to do our shift right. Then we'll plot our points. The first point is 4.3 and 2. Right about there. Our next point is 5, 3. And our last point is 7, 4. And we connect. All right, now let's go back, talk domain and range. Okay, the domain, exponents should be easy because you can put any number you want as an exponent. So your domain, or exponent, is always all real numbers. For the range, you just need to be careful and look for any shifts up and down. Here we're shifted up 5, so our range, instead of being greater than 0, but greater than 5. Domain and range here, again, this is an exponent. So our domain is all real numbers. Our range, again, look for shifts up or down. We're going down 4. So our range is greater than, in this case, -4. For logs, our domain, a little more complicated. Here you need to look for shifts left and right. Since this one has shifts, no shifts left and right, we'll go greater than 0. And our range, that's easy for logs. That is all real numbers. And finally, for the last problem, our domain, we have a shift. We went 4 right. So our domain, x is greater than 4. And our range for logs is easy. All real numbers. Okay, the rest of the hour you have stuff to be working on. You have videos to be watching. You have homework to be doing. Make sure you're working on something.